All right, so a little bit about me. Katie mentioned that I was born in Zambia. I currently live in Santa Barbara, California. Nice leisurely drive down the coast. I came here the long way via Canada and England, and originally born in Zambia. I've been building software professionally since 1996. I am the organizer of Santa Barbara JavaScript up the coast. I love jazz music. If I were stranded on a desert island and could take only one genre of music with me, it'd be jazz. It's America's greatest gift to the world. And I'm a dad of 2 school-age kids, stepdad to a 19-year-old college student, and husband of my beautiful wife for 5 years. That's me on Twitter. Follow me there for all sorts of non-technical tech junk. So I'm a software architect at Procore Technologies. We're a cloud-based construction software company, and we're growing like wildfire. Glassdoor rated us the #4 place overall to work in the US this year, #2 in tech, ahead of heavyweights like Facebook, Google, Microsoft, Amazon, et cetera. And we're actively hiring. We got a large React code base. If you're interested in that, see me after the talk or in the hallways. I'll be happy to put you in touch with the right people. And I do have some Procore keychain bottle openers, so hit me up afterwards if you want some swag. When I'm not geeking out over tech, I'm an avid scuba diver and an underwater photographer. It's a bad habit. Don't get into it. It's a major waste of money, but it's a lot of fun. All right, so why test-driven development? Well, let's take a step back for a moment for those who aren't familiar, and let's ask, what is test-driven development? Well, it's a software development methodology, agnostic of language, technology, platform, et cetera, and it consists of repeating a really short development cycle over and over again. Red, green, refactor. Red is writing a failing test and watching it fail, knowing it's going to fail. Green is writing just enough code to make that test pass and committing all manner of sins to get there. And refactor is changing the internals or optimizing the internals without breaking the interface under test. So there's all sorts of benefits to this methodology. Some are technical, some are process-based. But in my mind, the most important outcome of test-driven development is that a well-written suite becomes a shared, self-documenting understanding of the problem domain. So it's true that you can actually write decent tests after the fact, and you can definitely get equivalent coverage, code coverage, after the fact. The problem is you may be just asserting the correctness of bad code, or code that solves the wrong problem. In fact, you're kind of just verifying that the monster lives. Okay, wake up, everybody. I realize that this sounds really dry and boring, but the truth is TDD can and should be fun. First off, we get to hook into the brain's own reward system. We get to kick that little dopamine rush off for each passing test. And then when we get a whole suite of them, it makes our developer brains happy. So we all agree that test-driven development is awesome, right? So why would you not want to do this? It turns out, a few decades later, this practice is still controversial out in the wild. And there's various different pushbacks, most of which can be pretty easily countered. It does definitely feel wrong when you're first doing it. The rest of these can easily be countered by the benefits that are given. In fact, the last couple, change happens too quickly, solution isn't clear. TDD's strength is it lets you systematically close the knowledge gap between where you are and where you want to get to. So I think you could pretty easily throw these all in an episode of Mythbusters and they'd be firmly busted. So we agree TDD is awesome. Why test React components? Well, to start with, the web technologies that we all know and love are hard. And at the end of the day, we're building user interfaces, right? We're building something visual, and everybody and their mother has an opinion on things that are visual. And then in React land, we also have this beast called JSX. JSX looks an awful lot like the web technologies we're already familiar with. But in fact, it's not these things. JSX is just XML-like extensions to the JavaScript language. It's syntactic sugar for the create element method, which just produces React elements. It's not HTML. It's not CSS either. It is JavaScript. Got it? Awesome. All right, so we agree TDD is awesome. We think we should test our React components. How do we do that? When we think about testing React components, it helps to take a moment and think about the abstractions that React provides. And the primary abstraction that React provides for us is to model a user interface as a tree of components. And the docs actually give us some really helpful little tidbits as we read through them. They tell us that components are like functions. They take inputs and they return outputs that are React elements. And they go on to say that those React elements aren't DOM elements. They're plain objects, and it's not our responsibility to update the DOM. React DOM will do that for us. So there's some really good little nuggets in there that help us frame this discussion around how to test React components. The first is components are like functions that take inputs and return outputs. And there's little easier to test than a pure function. The outputs are React elements, not DOM elements. Those React elements are plain objects, and the DOM is none of your business. I want to dig into that last point a little bit more because it's important. It's reflected in the design of React. We actually get one package called React, and that is the core component abstraction. And we get a completely separate package called React DOM that's responsible for the details of rendering to the DOM, because the DOM is an implementation detail. Okay, so we saw from the docs that it's like React components like a function, take inputs and returns outputs. So if we take a component in its simplest form, this is a basic function component from the docs, and if we just invoke that and pass it an object with props, what we get back is a React element. It's a plain object that describes what might happen later if we hand that off to React DOM. This is not super useful on its own from a testing point of view. There's no API here. We might be able to make some useful assertions, but we're limited in what we can do. So React ships a package called React Test Renderer. We speak to it in JSX, and we get back an object with some methods on it, like this toTree method, and we get back, again, a plain object with a little bit more detail, and it also gives us an API by which we can query the returned element and make assertions about it. So the docs don't stop there. They go further, and they tell us that if you're writing unit tests, shallow rendering can be helpful, because it frees us from worrying about child components. Now, this assumes that unit testing is valuable to you, and this is another thing that's controversial still out in the wild. I believe that years of testing experience have taught us that based on cost and speed, you should spend most of your time at the bottom of the test pyramid on the unit tests. UI tests are important, end-to-end tests, service and integration tests are important, but they're more expensive, they're slower, tend to be more brittle. And from a TDD perspective, you're starting at nothing, so you're going to be building unit tests first. So with that in mind, the React Test Renderer packages, it ships a shallow render. Very similar, you talk to it in JSX, and you get back a plain object that you can query. It just doesn't render or instantiate child objects. The API is fairly limited, and the docs tell us that if you want a more robust experience with shallow rendering, to use the shallow renderer from Enzyme. This is a package from Airbnb. This library is also not without its own controversy, and there are shinier new toys making their way around the JavaScript ecosystem. There's definitely some legitimate criticisms of Enzyme, but on the whole, especially for shallow rendering, I think the pros far outweigh the cons. I wholeheartedly recommend it, and it's what I'm going to use for the rest of this talk. So, all that said, we now know the TDD is awesome. We all agree we should be testing our React components. We have some idea how to do it. What do I mean then by test-driven component development? What I'm really getting at is this tendency to conflate behavioral and presentational concerns. It's really easy, especially in this world of JSX, to go down the rabbit hole when you should be testing the behavior or verifying the behavior of a component. Nobody's ever done that, right? They've been in the middle of trying to make something work, and then they stand it up in a browser and go, oh man, that should have a drop shadow, that should be 3 pixels to the left, it should be red, etc. Nobody's ever guilty of that. So this is basically applying the methodology of TDD to focus entirely on the behavior of a component first, without worrying at all about what it looks like. We'll do that later. We know that TDD forces us to compose or output small, modular, single responsibility units, in this case, React components. We can then compose those together and write tests further up the tree to verify the composition of those. And then we can focus on how they look. We already know that HTML and CSS are hard, so let's put our brains on the back burner with a bunch of tests running on the behavioral side of things, and then we can focus solely on the appearance. So what do you think? Should we give it a shot? Cool. So we know that the first thing we're going to do is we're going to write a failing test. But first, let's have a little context. So we have a small, bright, hungry development team, and we've been approached by a client with a unique problem. The client's told us they're super busy, they have a really hard time keeping track of all the things they have to do. And what they want is an application where they can type in tasks, they can mark them as complete, they can see which ones are done and not, and they can remove old done tasks. And since nobody in the history of software engineering has ever built anything like this, our team has agreed that we can step up to the plate, and even though we don't know how to get there, we can use TDD to bridge that knowledge gap. So we're going to jump in 6 months into the development cycle. We're going to see where our team is. So we know that test-driven development produces, as an artifact, a self-documenting, shared understanding of the domain. So let's run the tests. And what did I do wrong here? Doesn't recognize that. Let's run the tests, and let's see what we get. And what we should get is we should get some idea of what the team has been up to in the past 6 months. All right, so we've got some output here. Let's see what they've been doing. So we can see, sort of in plain English, that they've written this to-do input component. Given a place to enter a new task, when a user presses enter and the task is not empty, it responds with the task. It looks like they've also created a component to hold a single to-do. Given a task, when displayed, it shows the name and whether it's complete or not. And they've written a bottom navigation to switch between active and completed to-dos. Cool. So that gives us some idea of what they've been up to. So what we're going to do, as we're stepping in here to help the team out, is write the glue for those things and put them together into a to-dos component that has the input, that shows individual to-dos, and lets us toggle between the views. So the first thing we know is we're going to have to write a failing test. So let's do that. So let's say, given a list of tasks, when displayed, it shows each task in the list. Sounds like a reasonable test, right? Everyone agree? Excellent. Okay, so that means that we're going to need some tasks to give this guy. So let's add some tasks. So let's create some to-dos. And we'll call them nonsensical names. OK, cool. Now we can pass these to our to-do component. So let's do that. All right, so we've set up our test. Now we need to make an assertion about it. So what's a reasonable assertion here? We've given it 5 to-dos. Why don't we say that there's 5 individual to-do components, 1 for each in the list? Sound reasonable? Cool, let's do it. So we're going to use an enzyme method called find. And we're going to find our previously written to-do component. And we're going to verify that we have the right number of them. Typos and all. OK, let's run it, and we should expect that test to fail. And it does. It definitely fails. It fails with a syntax error. Let's fix that first. Don't you love that? Where's my syntax error? Everyone help me out here. This is the perils of live coding. Oh, I broke my renderer here, didn't I? Oh, not Sathad. Let's do to-dos. That should fix that. OK, that's better. All right, so it still fails. And it gives us this really cryptic error. React create element type is invalid. So for those who have ever worked in a statically typed language, this is the equivalent of like a compile error. What it's telling us is that the file that has our component in it has nothing in it. And our test runner, Jest, is super helpful in that case. It gives us a plain object, and React has no idea what to do with that. So let's get ourselves to at least a meaningful test here. I think that's going to help us along. So let's grab our to-dos component, and let's just give it a basic React component called to-dos. Let's save that. Now we should have a more meaningful error. Great. So it says, given a list of tasks, when displayed, shows each task in the list. We expected 5. We got 0. Our test fails. All right. And so, armed with our failing test, we begin to cry. We feel like perhaps imposter syndrome is real. Maybe we can't not cut out for this programmer thing after all, and we should maybe find a new job. Don't despair. It's OK. This is actually progress. A concrete failure is way better than some sense that things are failing and not knowing what's going on. And also, and I can't underscore this enough, if you've never seen a test fail, it's really hard to have confidence that it's a valid test. If you have a whole suite of tests running in CI, and they always pass and you've never seen one fail, chances are you have at least some false positives. And one of the things that TDD gives us is the ability to verify upfront that a test can fail. This is super important. All right, so the next step in our short development cycle is the green step, and that's writing just enough code to make this test to pass. And that's what we're going to do, and we're going to commit all manner of sins and atrocities to get there. So we have this test. It's failing. I think probably the simplest thing that we can do to make this test pass is just to spit out 5 to-do components. Do we agree? Cool, let's do it. So let's grab our to-do component. And let's just spit out 5 of them. Oh, bear with me. There we go. Let's run it, and voila, it passes. Outstanding. We got some console errors there from prop type checking. Fix those later. The point is our test passes. You with me? Cool. So what did we do there? We did what's called a shameless green or sinful green, right? And even though the test passes, the implementation is not very useful because it's very tightly coupled to that test case. If we wrote another test case and threw it 6 to-dos, the test would fail, right? They're tightly coupled. So obviously, this is not going to help us much. But what we did was we described this perfect interface that we want for our component, and we achieved it with a passing test. More importantly, we got that little dopamine rush from our passing test. Our developer brain is happy. We no longer feel like failures. Maybe this imposter syndrome thing is not real. Maybe we don't have to quit our jobs. We can proceed. Cool. So now the next step is we're going to optimize the code under test without breaking the test. This is the refactor step. So let's go ahead and do that. So I think we know what we need to do here, right? We can't hard code these to-dos. We probably just need to map over the to-dos that were given to us and output those. So let's do that. So we have this to-dos prop. It's a map, so we'll get its entries array. And then it will pluck apart the values in there. We've got a key. We'll call it task. And we're going to have a Boolean whether it's complete or not. OK, so since we're mapping over something here, we're going to need a key. And we have a map that has unique keys. So we can use that as our key. So we use the task as the key. And then each one needs a to-do, which is going to be the same task. And then each one has an is complete. OK, let's see what we got there. Excellent. We got a passing test. Cool. Let's just, while we're at it, let's get rid of those console warnings. And we know from reading the docs and the tests that we have an onChange event. We don't need to implement it right now. We just want to verify that the console warnings are gone. And we also have an onRemove. Cool. We have passing tests. Outstanding. With no console warnings. So what did we do there? We committed this sinful green, the shameless green, that got us to a passing test. And then we went back and fixed it. But chances are, if you've been writing React components for a while, you know what to do, right? The clean implementation is obvious. You should just do it. So I'm not recommending that you necessarily do these silly little in-between steps unless you don't know how to reach the optimal solution. Sometimes it won't be clear how to get from your perfect interface to the right clean solution, so you get to refactor in small steps until you get there. And the gentleman that coined the term test-driven development, a guy named by the name of Kent Beck, in his book, TDD by Example, says that, and he says this over and over and over again throughout the book, TDD is not about taking teeny tiny steps. It's about being able to take teeny tiny steps. And he goes on to say that if all you ever do is take large steps, how would you know that a smaller step might actually solve the problem better? So that's it in a nutshell. That's TDD. It's just that cycle, and then you just repeat it over and over and over again until your application's done. So in the spirit of that, let's go ahead and do so. Let's repeat it. We have one test. Right now, this component is not super useful for us. We can display some to-dos, but right now the user can't interact with it. So let's write another test. Probably the first thing a user is going to want to do is to add a new task. So let's go ahead and do that. Let's write a test for that. Let's say when a user chooses to add a new task, it shows the new task in the list. Sound good? Cool. So we're going to need to render out the component again. And we'll bootstrap it with that same set of to-dos. Okay, there's our arrangement. By the way, a good test usually is in 3 phases: arrange, act, assert. So here's our arrangement. Now we're going to need to act. So we already have some components pre-built by our team. We have that individual to-do component. We've also got this to-do input component, and it's been tested. We know that it works, and it has a public contract. And in that public contract is a prop called onChange. So here, we're unit testing this component in isolation. We don't need to worry about how the internals of that other component behave. We're verifying that a callback this component provides to it works correctly and results in the right output. So what we're going to do is we're going to find that to-do input, and we're just going to directly call its onChange prop. The onChange prop is provided by this component. So we are going to find the to-do input component, and then we're going to get its props collection. And then we're just going to call the onChange method, but we're going to need to call it with something. We're going to need a new to-do. Let's say we're just going to call it to-do, and let's create that above. So let's create a new to-do, and we're going to do something. And we're going to fix that little typo there. OK, cool. So we're going to cast it back into the fiery chasm from whence it came. All right, so at this point, we've acted now. Now we're going to assert something about our action. So there's probably 2 assertions we could make here that would be equally valid. We bootstrap this thing with 5 to-dos. We could assert that now there's 6, and that's a perfectly valid assertion. But I always prefer specificity, and I think there's a more specific assertion we could make here, and that's that we can find a to-do whose to-do prop matches that exactly. So we're going to do that. So let's make an assertion. Let's expect that this is a really odd angle to type at. Pardon my typos. So what we're going to do first is we're going to find all the to-dos. And then we're going to call a more granular version of find called Findware. And Findware lets you run a predicate over all the nodes, all the children in the tree, and then it'll return those that match the predicate. So our predicate is going to be that there's a prop called, or a PZOP. We're going to find a prop called to-do. Oops. Pardon me. We're going to find a prop called to-do, and we're going to expect that it matches exactly the to-do that we just defined, and then we're going to check that it exists. And this is going to tell us that at least one of them exists, so we'll expect that to be true. Cool. And let's run the test, and we should expect the test to fail. And we have an unexpected token, so it's definitely going to fail. Where did we break it? Help me out, folks. First one to spot it gets a prize. It looks like it's here. Right there is the problem. All right. Good. OK, cool. So we got a failure, as expected. And the failure tells us that method props is meant to be run on one node, 0 found instead. And then it shows us the line where that occurs. Basically, it's telling us it can't find to-do input. Why? Because we haven't implemented it yet. So let's go ahead and implement it. Let's go back to our unit under test. So we're going to need to import that. And then we're going to need to render one out, right? OK. And then we also know, because we're invoking it, that we're going to have to give it an onChange. And for the sake of simplicity, let's just call it onChange. And then our job is going to be to implement that. So we know it's going to take it to do. Now, what are we going to do here? Well, we have some idea, because we've described the behavior that we want in our test. We basically have said that when the user triggers this change event, that our new to-do just magically appears, right? Which probably implies some state. We can't mutate the props that are passed in, So it probably implies that we're going to have state. It means we're going to need a stateful component. Now, in the old days, say, I don't know, last October, that would have meant that we would need a class component that extends React component. But the folks at Facebook that work on React came up with an alternative API that lets you hook into things like state management from function components. It's called the Hooks API. This is good because the overhead of classes is often not needed, and more importantly, JavaScript doesn't have classes. JavaScript just has syntax sugar on top of constructors and prototype chains. So we're going to use the useState hook. So we're going to need to import it first. And it looks something like this. You give it the name of the state container. There's a setter provided for you, and then we'll initialize it with the to-dos that are passed in, or if we don't get one, we'll just initialize it with a new map. And then what that means is that we should just be able to call the setter with a mutated collection. So we should just be able to do set to-dos and just add our new one. Initialize to false. OK, and we're almost done. There's just one more thing here that we're going to need to do to make this work. First one to spot it gets extra credit. It's all right, I'll give it away. Right now, we're still reading off the props, the read-only props that are passed in. So we actually need to read from our new state container. OK. Now, we have syntax errors all over the place. What did we do? We broke something. Oh, I know what it is. All right, and we're still broken. What did we break now? We broke something. We broke one of our previous tests, right? Yeah. Nope, that's it. Help me out, folks. What did we break? Where? In the source of the test? Right here? Right here? Ah, yeah, thank you. There it is, outstanding. Thanks for the help. Thanks for the assist. All right, cool. All right, so we have now, what we're going to do is we're going to fast forward another 6 months. You can tell, like, these things take a long time. For anyone who actually works in the real world knows that simple things take a long time in the real world. We're going to fast forward 6 months, and we're going to let our team continue along this journey of test-driven development before they've even looked at it in the browser. And then what's going to happen is they're going to have a fully functional application, and they haven't yet looked at it in the browser. It's probably going to look like crap. This is Amazon.com when it launched in 1999. By today's standards, this looks like absolute rubbish, but it was a very successful e-commerce site that allowed Amazon to become the juggernaut that they are today. And this leads us then to the really neat thing about test-driven component development, and that is that we can treat the visual look and feel portion of it as refactoring with passing tests. So we've already proven that it works. Right? Now we can actually set aside the behavioral part, which was hard. Right? And we can let our tests run, and now we can focus on something else that's hard, which is CSS and HTML, making things look great. So let's catch up with the team. And see how they've done. So the first thing we're going to do, of course, is to run our tests and see how far they've come on that component that we started helping them with. And what we can see is that they were able to select only the active tasks, complete one and verify that it is removed from the active tasks view, do the opposite with completed tasks. They can delete one, and they can remove one. So what I'm going to do here is I'm going to shrink these tests down. Not important that you guys can read the individual tests out there. We just want to verify that they're not breaking. And then we are going to stand up a browser over here. And we are going to, let's go ahead and get this guy right here. And I've got the dev server running in the background. And the first thing we're going to do is verify that, in fact, it actually does work. We've made this bold claim that we could build an application without looking at it. So let's just see. Can we add a new task? It looks like we can. This is good. This is progress. Can we? Let's see all the active ones to see if we can complete one. It looks like we can. Looks good. And let's see if we can remove that. It looks like it's gone. And then let's see if we can remove them all. OK, cool. So it works. It looks like crap. It's all just basic HTML components. There's no real pizzazz here, no style. If we put different length strings, they're all off. They're not lined up. It looks kind of like rubbish. So with that in mind, let's do a little bit of visual refactoring. I'm going to cheat here, and I'm going to use component library for some prettiness. And I'm going to use Material UI, not because I recommend it over other libraries. The real reason is a lot more practical, and that is that it's the one that's easiest to drop into a project with no config and no style sheets, and it just looks good. So I'm going to use that. And I think what we can do here, let's go ahead, swap that out for a card. Let's make it a flexbox. And let's make it not fill the whole width. Let's say 90%. Let's line it left. This is a really odd angle to type from. All right, that should be good enough. Cool. And then I think if we just wrap these guys in their own container and give it a flex of 1, and let's see what that looks like. That's it. There we go. OK. All right, we're getting somewhere. Cool. All right, so we can also, if we want, so we've just changed the markup. We could also like wrap this in a span, and everything should still work. Let's just make sure visually that it works first, and then we'll prove it by looking at the tests, and the tests are all still passing. So if you've written good tests, if you've written tests that are agnostic of implementation details, you should be able to move your markup around, style it, add additional wrapper components, and everything should still just work. Cool. So let's jump ahead just one more time here. Let's see what the team has been up to for the next 6 months, just doing visual refactoring, working with the client. And let's see what we get. Let's run the tests, just make sure everything is still running. And you can see now our UI looks a little bit glossier. We've got these great little animated radio buttons. Everything looks pretty cool. So let's just add one more task. Oops, well, JSConf is close enough. Let's mark that sucker off the list. All right, cool, the perils of live coding. And so what did we do here? We learned that test-driven development is a thing, that it's good, that testing React components is worthwhile and important. We learned that using this technique, we could free ourselves from conflating behavioral and presentational concerns, even though they're co-located in one file. We could focus on making components work, and then we could free ourselves to focus on how they look. We're happy, our customer's happy, and now we can get paid. And that's all I've got. Thanks a lot. There's the repo. That's me on Twitter.